Hello, Lawrence people and Kyle, I think. This is 3-2. This is the first part of 3-2. Measures of variation. Measures of variation. Okay, we, in the last section, we did mean, median, mode, and mid-range. We skipped range because range is an important part of variation. It's how a data set varies, okay? Variation is how spread apart the data is. Okay, so another way of thinking of that is how far apart your data set is, how spread apart it is, okay? So let me give you an example. I'll give you two data sets off to the side over here. Here's my examples, okay? Let's say we have an average of an 85 and we have another test that we had an average of an 85, okay? So we use X bar for the symbol for average. And I'm going to talk about something called a standard deviation. You guys have heard that word before, maybe? Standard deviation. I'm going to say this one has a standard deviation of 5 and this one has a standard deviation of 10. Okay? So here's what this means. If I'm talking about how spread apart your data is, 85 lives in the middle because that's the average. 85 lives in the middle over here, that's the average. If I'm just looking at average, these two classes, whatever I'm talking about, look identical to each other. But when we talk about how spread apart the data is, 5 is my standard deviation, so if we go 5 units on either side of 85, that would give me the range from 80 to 90. Now, that doesn't mean every single data value lives between an 80 and a 90. We will find that if my standard deviation is 5, a certain percentage lives between an 80 and a 90, and it happens to be 68%, okay? According to what's called the empirical rule. We'll go over that. I think maybe in this section, actually, we do the empirical rule, okay? So what the empirical rule is, some guy came up with this rule. He looked at data set after data set after data set, hundreds, thousands of data sets, and he came to the conclusion that when you calculate your standard deviation, approximately 68% of your data, after doing data set after data set, approximately 68% of your data lies within one standard deviation of the mean, okay? If I would go out to another standard deviation, it would go 75 to 95. Approximately 95% lives within that data, within that range. If I would go 3 standard deviations, it would be 99.7% of your data, okay? He just crunched the numbers and did data set after data set and found that the trend was about 68%, about 95, about 99.7% of your data, okay? So I can conclude that about 68% are gonna live within an 80 and a 90. But over here, if my standard deviation is 10, then that would go from 75 to a 95. So about 68%, or the majority of my data, would live between a 75 and a 95, okay? So even though the average is the same, which group is more consistent in their scores? Yeah, the 5, the standard deviation of 5. This has a smaller spread out data, right? My range is going to be smaller. My variance, the way that it varies is going to be smaller. Standard deviation is smaller versus these guys over here are way, way, way spread out, okay? So even though your average is the same, mean is the same from section 3.1, your standard deviation or your variance, how spread apart the data is, that's what we're talking about in this section. The spread of the data is going to be larger with a larger standard deviation. What?
This is kind of like how bell curve works.
What?
Like
what?
A bell curve.
Yes. Mm-hmm. Yeah. We're going to be putting this stuff onto a bell curve, right? Exactly. Mm-hmm. Yep. You'll see that here in a second. Okay, so the round off rule. They're going to start us off. Round off rule for measuring variation. Carry one more decimal place. Okay, we already have talked about that rule. So if let me see if our first set of data, right here, our first set of data is these guys here. We're going to carry 2 decimal places when we do the variance and the standard deviation. Okay, the range. Can we do one more data value when we're doing range? Range is just the largest minus the smallest. Let me see what they say specifically. When rounding the value of a measure of variation, carry one more decimal place. Okay, well, but range is just what it is. I don't know. We're not going to carry one more decimal place for the range because it's just subtracting. Right? You guys know what range is? Okay. All right, so here's the deal. I put a star here, and we're going to talk about this example really quick because it talks about how data varies, okay? This is kind of following a bell-shaped curve right here, except this bell-shaped curve is really tall, and this bell-shaped curve is really spread apart, okay? Now, here's what happens. when you have, it's talking about quality versus by reducing variation, okay? So variation typically is not considered to be a good thing. If I go back to my example up here, do you know which class I prefer? They both have an average of an 85, but which class do I like better? The first one, because even though we have people up here that are scoring 95, I would rather have the first one, because it's very irritating for me as a teacher when I have the average is an 85, but then I have somebody that scored a 40 and then some person that scored 100. Like, what the heck? I taught them the same material. What happened? Like, you know, it's very frustrating for me, versus if I have a smaller spread of data, I kind of know, okay, you know, like we're just missing bits and pieces here, versus having a spread of like data spread all the way apart and I don't know what to reteach. Does that make sense? Okay. So technically, or most of the time, variation is not considered to be a good thing. In the real world, here's an example of this. What we're talking about here is we're talking about a bank teller, and this works in Walmart. So maybe let's relate this back to Walmart, okay? So Walmart, you walk into Walmart and a lot of times like all of the lanes in the front are closed, right? Except like maybe 2. Yeah? Shake your head yes. Okay. Like you go into Walmart, there's only like 2 checkout lanes where they actually check you out, not the self-checkout, but like they check you out. You do self-checkout all the time, so it doesn't matter, right? But there's like 2 lanes open where they check you out and that's it. And you're like, why do they have all these lanes when they only have 2 open? Okay, so here's the deal. If we only have a few open, we know that we're gonna end up probably waiting in that line for a while, right? So this is the wait time, okay? The times are going to be higher, okay? But if they have multiple lines open, sometimes I'll wait like 5 minutes versus sometimes I'll wait 30 seconds, okay? Do you know what people like better?
30 seconds.
I mean, obviously they would like the 30 seconds. But if you walk into Walmart or walk into a bank or something, you don't know whether you're going to wait 5 minutes or you don't know whether you're going to wait 30 seconds. They would rather know that I'm going to wait 5 minutes every single time than know that sometimes I'm going to wait 5 minutes, sometimes I'm going to wait 30 seconds. Does that make sense? Like they would rather have it consistent and know exactly how long they're going to spend in a bank, right? And you do that by reducing variation. So even though I could get really lucky and spend 30 seconds in there, a lot of people like the consistency of knowing I'm going to be in there for this long, right? Even if it's a longer period of time, okay? They don't like walking in there and having 30 seconds the first time, and then the second time you go in and you're like, oh, last time I waited 30 seconds, and then you're mad when you have to wait 5 minutes. Does that make sense? Like you guys have all had that happen before, okay? So they would rather have the consistency by reducing variation. Do you see how like there's no dots out here? That's because all of those dots are sucked in and we might end up waiting longer, but it's more consistent, okay? So reducing variation, that improves quality. That's just a thing that they try to do in the real world, whether it's waiting in a bank or producing, things on a conveyor belt or whatever. They try to improve quality by reducing variation. People want to know exactly what they're getting, right? That's just how it works, okay? So by one of the measures of variation is range, and let's see, the range only uses the maximum and minimum number. We take the max minus the min. So it does not take into consideration all of the values. It does not take every value into account. We don't care what the middle numbers are. We only look at the high and the low values for the range. Make sense? Okay. The range is not resistant, which means that if I have an outlier like 2, 3, 4, 5, and 53, okay, my range without those is going to be 3. My range with the outlier changes to what? 51, right? So it is not resistant. It will change resistant. It will change significantly if I have an outlier. Make sense? The range is huge. And again, it does not take every value into consideration. So I didn't even look at the 3 and the 4. Or the 5, I guess, when I do or the 5 the second time I did it, right? I don't care what those numbers are, right? It only takes the first and the last value into consideration, okay? All right, so range. Find the range of these values. The highest number is 55.6. And the smallest number, 14.1. Can you do that in your head? Yes, you can.
41.5.
41.5. Awesome. That is my range. Okay, and we're not going to carry one more decimal place for the range. We will for the standard deviation and that stuff. Okay, but not for the range. All right, are you ready? Ooh, we're going to calculate some standard deviation and stuff. All right? Buckle in. Here we go. You need a calculator. You guys all have a calculator? Grab one. You're going to be doing some calculations for me. It's a little tedious. I will only make you do one on your homework assignment this way. Okay? I will only make you do one standard deviation on your homework assignment this way, but this is the longhand way. We have two formulas that we get to use. Okay? First formula, standard deviation. This is how we calculate. Standard deviation is S. I'm going to write variables in here. Standard deviation. Write these down so that you know what this is talking about. Okay? All right, we have this guy. What's the E mean? What's the E mean? The sum. So I'm adding these together. The sum. Okay? What are the X's? What's X mean? What does X mean? Yeah, like it's each data value. Each value. So like each one of these is an X. This is like X1 and X2 and X3. Those are all my X's. Okay? What does X bar mean? The average or the mean. Okay, so we have to calculate the mean from our data. Okay, and then what's N? What's the other value in there?
Your number of
Number of numbers.
Number of numbers.
The number in your data set, or the number in your sample. The number of numbers. So if I have 5 numbers, I would plug 5 in for N, right? Like we have. Okay? That's one way of calculating standard deviation. Another way that will give us the same kind of mostly answer is to do it this way. Okay? This one looks uglier. This one is actually not uglier of a formula. It's actually maybe a little bit faster. Okay? So N again is the number of numbers. Same thing here. Okay? We've got 3 N's. 3 places. X again is your data. So each value. And that's it. We only have N's and X's that we need. Okay, we don't use X bar in this formula. That's why it makes it a little bit nicer. Okay, no X bars. All right. Before we actually calculate a standard deviation, let's talk about him. So I talked about standard deviation above, and it talks about how spread apart the data is. So if the standard deviation is higher, that means bigger spread. Bigger spread of data. Okay, and then lower would be, I'm going to say more consistent. More consistent. Okay, your data is closer together, it's more consistent with a smaller standard deviation, relatively. Okay, good? Got it? Okay, bullet points. The standard deviation is the measure of how much data deviates, I like that word, away from the mean. How far apart the data is away from the mean. The value of the standard deviation is never negative. Circle that. You will never have a negative standard deviation. You never have a negative standard deviation. Okay, what happens if your standard deviation is 0? Your deviation is 0. Yeah, my data would look like an 85, an 85, an 85, an 85, 885. All of my data would be 85s if I have a deviation of 0. It's not deviating at all, right? To deviate means to be different. Deviate means be different. We have no differentiation, so our deviation is 0, okay? Larger values of S indicate greater amounts of variation. The standard deviation can increase dramatically, circle that, with 1 or more outliers, okay? The spread of my data is bigger with an outlier, so my standard deviation is going to increase with an outlier. It's kind of like if you drop a 0 in the grade book. Your average, okay, might go down, but your deviation is going to be bigger as well because you're deviating a lot from your average, okay? Units of standard deviation are the same as the units in the original data values. So if I'm talking about feet, my standard deviation is in feet. If I'm talking about seconds, my standard deviation is in seconds, okay? And then, let's see. I'm not going to talk about the last bullet point yet. We'll come back to him, okay? All right, notation. Your sample standard deviation is S. Okay, the population standard deviation is this guy. He is called sigma. It's a circle with a hat on him. Remember that. S and sigma, circle with a hat. Kind of like a hat on one side.
Like a toupee.
Like a toupee. No, that's not a toupee. A toupee is like a piece of hair that goes on your head. It's like a one of those the bill of a hat going to one side, like turned sideways. A hat turned sideways. Bill of your hat's gone sideways. Anyway, so population standard deviation. What's the difference between sample and population?
That was awesome.
You're thinking of Trump's hair.
Yeah.
Trump is not a toupee.
It's Donald
Not
Trump.
Donald Trump's
Quick,
hair.
Get out your orange, quick.
Okay. What's the difference between sample and population?
A sample is part of the population.
Sample's the data that we gather.
Mohawk.
Population.
This is usually what we have.
A mohawk is like.
What we have. Okay, the population. What we
Like it's
are
a unicorn. That's what it is. It's a
trying to
unicorn.
represent.
Or a normal.
Okay? We find the sample in order to represent the population. Okay, so we're trying to make these figures or try to make these guesstimations to represent the population. All right? Trying to represent the population because we don't have all the population data. All right, let's do it. Here we go. You got your calculators out? We might get through one of these and then we'll be done. Okay? All right.
No, I see.
Here we go. I will make you do one of these. One of these like your homework assignment, like one of these. Okay? You only have to do it this once for homework. Okay? We have two different ways of calculating standard deviation. I'm going to write down the formulas here, and I need a paper. Can I steal yours? Even though you're writing? Sorry.
You can steal
So
mine.
that way I don't have to go back and forth.
Not right.
S. Write this down.
Hey, write it on my paper.
I don't think she has a
The sum of x minus x bar squared all over n minus 1. All underneath of a square root. Okay, that's the first one. I'm going to write the formula down for this one over here. I should have just included this, but it somehow
So,
got taken off.
You're a math teacher and you don't even know this. Why are we ever gonna?
Okay, have you met your English, business, and science teacher?
Luke.
science.
Be nice.
Mr. Booth?
No, I do not have these formulas memorized. You don't have to have everything in math
Mr. Stroud knows
memorized.
about the biology.
He knows like
Okay, there you go.
No, but I honestly think Mr. Streff knows how to do this. He just has taught it so many times that he just doesn't care anymore. Like it's
Okay.
his like 30th year teaching the exact same thing.
So I just recopied these formulas from the front side. Okay, the second one looks like the uglier formula, but it is not that bad. Okay. All right, here we go. These are our data values. We don't necessarily have to have them in order. Do you want them in order?
Yes.
Sure? Okay, let's do it. 14.1. Because sometimes it's easier to like maybe see the trend if you 22.4, 23.1, 38.5. We only have 5 numbers. And 55.6. Okay. The first thing that we need to do in the top formula, we have to rely pretty heavily on X bar. What's X bar mean again? The mean or the average. Okay? So we need to average those together. We've already done that at some point. Do we have that average though? What is X bar? Somebody give that to me. No, well, I mean we did it in 3.1. We did it in section 3.1. Somebody add those together and divide by 5, would you? We did that in section
I thought
3.1.
you
But
meant like of this specific data set, and I was like, what?
yeah, they've been using this specific data set the whole time.
Oh wait, we have.
Like in section
but
3.1,
it is
Verizon
the
data
exact
speeds,
same.
yeah?
Sure,
Okay.
Yeah, you're right.
Somebody got it?
You're right.
The mean?
I got 30.7.
30.74?
Yeah.
Yes? Okay, and it says carry one more decimal place than what we have in our data set. So 0.74, that's what we want to use. Okay, now in the formula, we need x minus x bar. So we're going to do that right here. What does x minus x bar look like for the first number? X minus x bar. How do we calculate this thing right here?
14.1 minus 30.
Yep, it'll be 14.1 minus 30.74. That's what it'll look like for the first one. Okay, give me that number. 14.1 minus 30.74. 74.
Negative
7.4 or 7.5?
7.4. I wrote 7.5. 7.4.
16.64.
Negative 16.64. Okay, now let's just go ahead and fill in the next column. What do we do with that number?
Square.
You square it, okay? If you square it, will it become positive or stay negative?
Positive.
It will become positive, and it is something. What is it?
Hold on. Let me figure out how to square things. There
You just hit the
Oh,
square
that
button.
makes sense.
Okay, what?
it is.
It'd be the same
276.
distance.
Two what?
If it was negative or
Oh, wow.
positive.
I'm so
You're
confused.
calculating just the distance, and the distance.
Somebody
is
got the
same on
square?
both sides.
I squared it, but it stayed negative.
What did you get?
Negative
Like-
276.
No.
Yep.
Jake-
What? Oh, oh, oh.
276.8. Yeah, I got
276.8?
Why did mine stay negative?
Point eight what?
you.
Let me see what you did, Jake.
0.88?
Yeah.
Okay, yes, it's because you don't have it in
Yeah, it's
parentheses.
in parentheses.
So if you do that,
So
Jake,
it's assuming
just,
there's a negative
yeah,
one
yeah, yeah, yeah.
times
So when you hit the square button, if you just like square this number, it's gonna
276.
like include the negative on it because it's not taking the whole thing into like parentheses. So if you choose to do that, just leave the negative off on the
Wait,
other column.
I
Why
got
don't you go 8, 9?
I
Eight
got
what?
8, 9.
8, 9?
9.
Okay, perfect. All right, second one. Let's do this one now. 22.4 minus 30.74.
Negative 8.3.
Negative 8.3.
3.4.
34. Okay, let's square it.
69.56.
69.56. Okay. All right. Do I need to keep writing the work down? 23.1 minus 30.74.
Negative 7.64.
Negative 7.64. Okay. And square?
58.37.
Bless you.
58.37. Perfect. Okay. It's good to have you back, Haley. 38.4 or 5 minus now we're in the positives.
It's 7.76.
7.76 squared.
60.22.
60.22.
Next one is 24.86
24.86.
and 618.02.
618.02. Okay. All right. This is the tedious part, and I only make you do this once for one problem. Okay. So this is the ugly part. All right. Let's go back to the formula. Ready? Let's see what they say. They want the sum of all of these. So what does that mean? The sum of all of those.
Add them all up.
Add up this second column. So
Hold
we
up,
want all
hold
of
up.
those added together. A couple people do it so we make sure we get the right answer.
I think we did number the middle one wrong.
Okay, do it again.
What?
Do it again.
I got 8.64.
For which one?
23.1.
Yeah.
Minus 30 would be.
Oh, 23.1. Oh,
What did you
shoot.
think of?
22.1. My bad. Sorry,
Okay, you're
guys.
fine. You're fine. Okay, add them all up. Somebody get an answer? What? Shout it out when you get it. You're just adding them, not dividing by anything, just adding them. Daniel got it?
1083.06.
1083.06?
Yeah, that's right.
Like that? Okay, so that is the sum. That number goes here. The square root of 1083.06. Ugh, how awful. Okay? Questions on how we get these things? That's what the sum of all of those means. Okay? N minus 1. What's N?
4, 5.
N is 5, right? So 5 minus 1, let's just go ahead and do that in our heads, 4, okay? So if you have that number, take it and divide by 4, and then you're going to take the square root of that, and then give me the standard deviation.
16 point. How many decimals do you want?
2.
16.45.
4, 5. Okay? And that is S. So S is 16.45. Actually, read me out like the big long one. I'll write that down here.
16.45493847.
You don't have to write that down. Okay? Just write down 16.45. But we're going to see how close this next formula gives me to the actual answer. Okay? All right.
Tomorrow.
We get out of here at 15. No, we got time. We got time. We're fine. Okay, let's do this next one. This next one is a lot shorter, but I am missing a fifth block here, so maybe like make a fifth one. Sorry. For some reason I only have 4. And let's put these ones in order as well. So 14.1, 22.4, 23.1, 38.5, 55.6. So you're gonna have to add a little column onto the bottom. Okay. Blah blah blah. And then we're gonna square each one. So we're just squaring. We're just squaring. Somebody got these numbers?
The first one's 198.81.
The last one is
198.81. Okay.
3,091.36.
3091.86.
Should do the
Oh, the second
class.
one's 501.76.
Luke, did I get that right? 3091.86?
Yeah.
Okay. Haley, what's the second one?
501.76.
501.76. Okay.
The
Anybody else?
middle one is 533.61.
Okay. What else? Fourth one. You're just squaring these numbers.
Get it, Jake. Fast.
No.
148, 1,482.25.
25. Okay. Now these numbers should go up, right? Like in order because our other numbers were in order. Okay. All right. Now we just have to plug stuff in. So we're doing the square root of all this stuff. Blah. N is the first thing that we put. What's N?
5.
5 times. This guy says the sum of all the x squareds. The sum of all the x squared. So we got to add those together. Somebody else do the sum of the first column. If you want a shorter one. Tell me when you get a number.
Okay.
What you got?
5,807.79.
5807.79.
Yep.
Okay. Somebody have the other one?
153.7.
153.7. 7 what? Oh, just 7. Just 7 because we only want a decimal place. Okay. All right. So this one right here, again, this is kind of tricky to read this. This is all the sum of all the x squareds. The sum of all the x squared is the 5807 number. Okay. Minus. This one is a little bit different. This is saying the sum of all the x's. What's the sum of all the x's?
153.
That's the 153, and I want to square that number. Does that make sense? Do you see the difference between the two? The sum of the x squareds versus the sum of all the x's. That number squared. Yes, Jane? You think Luke did something wrong?
Yeah.
Did anybody else add the second column?
Yeah.
Yes. You got the same thing?
Yeah.
Then you didn't do something right. You probably flipped a number.
Dang it.
Or missed a decimal or something. Okay? And then the bottom one is 5 times what? 4. So that we're dividing by 20. Okay? If you want to do this in parts, you can. So yeah. 5 times that number minus that number squared all over 20. Take the square root. Can you do that? You should get, we know what you should get. You should get something close to 16.45.
All right, let's see.
See if
what
it rounds to
we're
that.
getting here.
It does.
It does, yeah. Do you have the full decimal?
I don't think it, well, since I didn't get rid of all decimals in the first number, it's not gonna be exact.
Okay. Okay. We'll wait.
What is the loan?
I got 16.77789.
Are you sure?
Yeah. And that's using parentheses and everything.
I got 16.4548777.
16.4548. Luke, say that again.
777.
777.
Yeah.
I got a way off number.
You got a way off number? Okay, now,
Claire, did you
Is
put
the
in?
20 like still
Underneath.
square root? Okay.
the 20
Yeah,
is
so you
underneath.
divide that by
So
10.
if you're gonna do this, you need to take 5 times this guy minus this guy squared, enter probably,
divide by 10.
divide by 20, enter, take the square root, enter.
I
Yeah,
just did
yeah.
it all in one
You have
shot.
to be very, very careful, okay? All right, so 16.45 is what it rounds to, which is the same as what up here, but these exact numbers are just slightly different, okay? But if we're only rounding to 2 decimal places, it should be okay, right? They should be pretty similar to each other. So it does not matter. Now, question. Do you like the top one or the second one better?
The top one.
You like the top one better?
Honestly, it's.
I like the second one better.
There's
All you have to do
likely
is
to be-
add them and square them and
You're
that's
less
it,
likely
right?
to mess up, I think.
Yeah, that's true. That's
The
true. You
number
might
is
be less likely to screw it up. Okay. But you just might have to like write it out in parts or like solve it in your calculator in parts. Okay? All right. That's as far as I'm going to go today.
I don't have this calculator.
Okay. On the homework assignment, I'm going to change something just a little bit. We'll get rid of some data values. Can we do that?
Stupid. And then
Yeah.
Go to, we don't know how to do 1, 2, 3, 4 yet. Let's have you do, we'll have you do range, variance, and standard. You don't know how to do variance yet. So we'll do variance in a little bit. Standard deviation. So range and standard deviation, but I'm going to lump off and let's just do the first 4 numbers. Can I do that?
Oh, that's so nice of you.
Yeah, you're welcome. Okay, so just do the first 4 numbers. You can cross off the other numbers just because I don't want it to take you forever. So find the variance and the range. You can do the range as well with just those 4 numbers. Range and standard deviation of just the first 4 numbers.
What about
You
on
can use either formula. I don't care which one you use.
What about 7?
Okay? 7, we're going to do a different way. We're going to cheat and have the computer do it for us. Okay?
Ah,
But
love
6
cheating.
is the only one that I want you to do the longhand version, so use the formula. So that's all I want you to do for homework. Range and standard deviation for number 6. Using either formula, I don't care which one. Only those first 4 numbers. Got it? Questions? Okay, there you go.
Can you come here? Mom?
That is all.